Sri Venkateswara College of Engineering from Department of CSE. Today I am going to give you all a presentation on lexical analysis. Table of contents. Introduction to the lexical analysis phase. Role of the lexical analyzer. Input buffering in lexical analysis. Specification of tokens. Recognition of tokens. Lexical errors and error handling. Lexical analysis tools and techniques. Lexical analysis in compiler design. Challenges and considerations in lexical analysis. Conclusion and key takeaways. Introduction to the lexical analysis phase. The lexical analysis phase, also known as the scanning phase, is the first phase of a compiler. It involves analyzing the stream of characters that form the source code to recognize the basic language elements or tokens. This phase is crucial in identifying and handling errors and plays a significant role in the efficiency of the entire compilation process. Role of the lexical analyzer. Token identification. The primary role of the lexical analyzer is to identify different tokens in the source code. It analyzes the input stream character by character and identifies the language's reserved words, operators and symbols. Error detection. It is responsible for detecting lexical errors such as invalid characters or undefined symbols. The accurate detection of errors is vital for maintaining the integrity of the compilation process. Token classification. Once tokens are identified, the lexical analyzer assigns a token class or category to each of them. This classification is essential for the subsequent phases of the compiler. Input buffering in lexical analysis. Buffer management. The lexical analyzer manages the input buffer to efficiently process the characters from the source code. It ensures a smooth and organized flow of characters for analysis. Character consumption. As characters are consumed from the buffer, they are evaluated for token identification. The input buffering mechanism supports this sequential consumption for analysis. Buffer optimization. Efficient buffering techniques are employed to optimize the processing speed, ensuring that characters are readily available for lexical analysis. Specification of tokens. Token structure. The lexical analyzer specifies the structure of different tokens, including identifiers, constants, and special symbols. Each token type is defined with specific characteristics for recognition. Lexeme representation. It defines the lexeme representation for each token type, outlining the sequence of characters that form a valid token within the language's syntax rules. Pattern matching. The specification process involves pattern matching to ensure that tokens are correctly identified and associated with their respective classifications. Recognition of tokens. Lexical phrasing. The lexical analyzer performs lexical phrasing to recognize and validate the tokens against the defined specifications, ensuring they adhere to the language's grammar rules. Token extraction. Upon recognition, the extracted tokens are passed to the subsequent phases of the compiler where they undergo further processing and analysis. Error reporting. If an lexical errors are encountered during token recognition, the analyzer is responsible for generating accurate error reports for debugging and correction. Lexical errors and error handling. Error identification. The lexical analyzer identifies various types of lexical errors, including unrecognized characters and invalid token formations. Error classification. It classifies the identified errors based on their nature and severity to facilitate appropriate error handling strategies. Error resolution. Efficient error handling mechanisms are employed to resolve lexical errors and provide meaningful feedback for developers. Lexical analysis tools and techniques. Three automated tools. Leading lexical analysis tools offer automated capabilities for tokenization, reducing manual intervention and enhancing efficiency. Five advanced techniques. Advanced lexical analysis techniques encompass sophisticated algorithms to handle complex token recognition requirements. 2K scalability. The tools and techniques are designed for scalability, catering to large databases and diverse programming languages. Lexical analysis in compiler design. Integration with syntax analysis. The output of the lexical analysis phase acts as input to the subsequent syntax analysis phase, ensuring a cohesive compilation process. Token synthesis. The synthesized tokens provides a foundation for phasing and semantic analysis, establishing the structural elements of the code. Code optimization. The tokenized representation is further utilized in optimizing the generated intermediate code, enhancing the performance of the compiler. Challenges and considerations in lexical analysis. Language ambiguity. Handling languages with ambiguous syntax and multiple interpretations poses a challenge for accurate tokenization. Performance trade offs. Optimizing tokenization speed while maintaining thorough analysis requires thoughtful consideration of performance trade offs. Debugging complex tokens. Identifying and debugging complex tokenization scenarios involving nested or composite token structures demands meticulous attention. Extensibility and customization. Addressing the need for extensible token definitions and customizable phrasing rules enables flexibility in language support. Conclusion and key takeaways. Critical compiler component. The lexical analysis phase forms a critical component of the compiler, laying the groundwork for subsequent compilation stages and overall code processing. Role in code understanding. It plays an essential role in understanding the semantics, structure, and syntax of the input code, facilitating accurate processing. Importance of efficient tokenization. Efficient token recognition and error handling are crucial for ensuring the functionality and reliability of the entire compilation process. Continuous advancements. Ongoing advancements in lexical analysis techniques contribute to the enhanced code analysis and language support in modern compilers. Thank you so much for watching my presentation. If you like my presentation, please do like, share and subscribe.